Hi everyone, in today's video we will discuss about the safety aspects, maintenance and troubleshooting of hydraulic systems.
Scene number 1. In the last video, we discussed the safety aspects, maintenance and troubleshooting of hydraulic systems, and in continuation, here we are going to discuss the safety aspects, maintenance and troubleshooting of pneumatic systems. Let us discuss on safety precautions on pneumatic systems. When other conventional energy sources are thought to be dangerous, pneumatic systems are frequently used. Commonly, pneumatic tools and equipment are employed in place of high voltage electricity and combustible liquids. People can suffer serious harm from compressed air. Never allow compressed air enter a human cavity such as the nose or ear, and never shower anybody with it. Oil droplets and other pollutants in the compressed air that is emitted through the exhaust can harm the eyes and respiratory system. The entire circuit should be checked for any potential loose pieces, broken pipes or abnormal pressure before turning on any systems. Work should be stopped right away if a system leak is discovered. While compressed air is still running through your system, avoid making any alterations, big or small. First, turn it off. To prevent attachments from being ejected during tool operation, always employ a safety clip or retainer. To avoid accidental disconnection while in use, make sure that all hose connections are fastened with positive locking mechanisms. Use air compressions away from combustible objects in a well-ventilated location. Avoid placing anything that can obstruct airflow on or against the air compressor. Never use a pneumatic tool at a pressure higher than the manufacturer's recommendation. Use connections and hoses with PSI ratings that are equal to or higher than the air compressor's maximum pressure. The shut-off valve for compressed air should always be accessible and visible. Never point any portion of the body, including other individuals, at a pneumatic tool or nozzle. Use just the attachments that the tool's manufacturer suggests you use with it. Maintain pneumatic tools as directed by the manufacturer, including cleaning, lubrication, and general upkeep. A pneumatic tool should never be carried by its hose. Only grounded outlets should be used to plug in air compressors. Scene number 2. Basic pneumatic system maintenance and troubleshooting. Once in a week. Drain compressor, tank, filter, bowl, and any air lines that have drain cocks. Check compressor crankcase oil level. Check compressor safety relief valve. Once in a month. Inspect discharge air filter. Check pressure reducing valve setting. Once in every 3 months. Change crankcase oil. Oil the compressor motor. Check compressor pressure switches. Once in every 6 months. Check for moisture, oil and dirt in airlines. Clean the intake air filter, felt and screw types. Check the compressor belt. Check the pressure relief valves. Check calibration, operation, nozzles and restrictors of transmit temperature controllers, pressure controllers, thermostats and humidistats. Check piping of pressure transmitters and controllers. Clean elements and humidistats. Once in year, replace cartridge type intake air filters. Check calibration of receiver controllers. Check valves for tight close-off. Troubleshooting pneumatic system. Low operating pressure. For a pneumatic system to operate well, adequate air pressure is necessary. System problems are significantly exacerbated by air pressure problems which have a variety of root causes. While the compressor is frequently the cause of air pressure loss, other factors such as loose valves and connections, filthy filters, and poor maintenance practices can also contribute. However, problems with either too low or too high a pressure will affect the system's overall effectiveness and running expenses. When there is inconsistent or no airflow, the intake filter may experience pressure problems. The intake becomes clogged if the filter is rusted or broken. Simply remove the intake filter, clean it or replace it to solve the problem. If the system is underpowered or the machine isn't working, you most certainly have a leak someplace. Using an aerosol sprayer that can be filled with soapy water or light oil is the most effective approach to identify leaks. Spray liquid down the length of the hose starting at one end. If there are leaks in the hoses or attachment, bubbles will form where the two come together Bubbles indicate air leaving. Low air quality. Components on the demand side, such as pressure valves, flow control valves, and linear or rotary actuators, are impacted by air quality. On certain parts, poor air quality can have a cascading effect on the entire system. Severe rust is evident on the pistons. If there is even the slightest indication of corrosion, there is a moisture issue. A pneumatic system can suffer severe damage from moisture, which can enter a system in a number of ways. Prolonged moisture exposure causes corrosion, which spreads to the other system components and causes a variety of issues throughout the entire system. One of the most frequent issues with pneumatic systems is valve spool jamming, which is typically brought on by corrosion or system debris, which can make a valve stick and not open properly. By changing clogged filters and doing routine maintenance on your machine, you may prevent valve spool jamming. Poor electrical system. The system won't function properly and could be harmed if the voltage is unstable, out of the operational range, or both. Important information. Make sure the power is off and that there is no air flowing through the equipment before checking voltage or power difficulties. Atmospheric condition. Deformation and misalignment. Metal expands and contracts at different temperatures as it is heated up. Metal parts may get misaligned or distorted as a result of the expanding contracting cycle, which will reduce the system's overall efficiency. Make sure to keep your compressor away from sudden temperature changes and pay attention to the outside temperature when working with your system to prevent these problems. Pneumatic installations. Any pneumatic system, no matter how good it is, will fail prematurely due to inadequate installation. Side loading, which happens when a load is applied to the piston rod without support or guidance, or when the mounting and piston rod connection are out of alignment, can result from improper mounting. Pneumatic cylinder repairs, for instance, will be required if side loading develops. There are numerous strategies to reduce side stresses, but nothing beats accurate alignment during first installation. Selection criteria. It can be difficult to choose the right pneumatic system for your particular application, from selecting the correct directional force required to figuring out the load requirements for your specific process, and it's easy to choose the wrong product despite the fact that pneumatic systems are simple in design, easy to install, affordable in price, and durable in terms of performance.
I hope after watching this video, you can know the safety aspects, maintain them, and troubleshoot the pneumatic and hydraulic systems. Thank you for watching. Have a wonderful day.